Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome back again to the NPTEL online certification course on research methodology for planning and architectural studies. In our last three lectures, we have gone through three different case studies where we have seen different application where like impact of say Delhi Meerut Expressway. Somewhere we have seen that how to evaluate the facility location for park and ride. So applications are different, their subjects, their background, objectives were different. So the main purpose of telling you all this case study is just to tell you that how in different way different methods can be used in a quantifiable way to come up with a good research. And all these papers that so far I have presented to you, they all were published in good journals, so it has certain sort of peer reviewed value. So that means that they have some worth of that kind of application. With the same line, today we'll be discussing the case study number 4, and now this is little different. The overall area of research is different than what we have discussed previously, that were much more on the transportation, land use. Now we'll be focusing on something different, infrastructure, and very important one, the water infrastructure. So with that, let us start the lecture number 43, quantitative research, case study 4. So in this particular lecture, again we'll see another application, and in this case definitely the method is different and very important one. Let us go slide by slide to understand it in a better way. And finally we'll summarize our understanding and also discuss the takeaway from this case study. And the area is very sensitive and very important, and we can relate to our day-to-day scenario. So this is all about the water infrastructure, and in this paper we have studied the determinants of per capita water supply in Indian cities with low surface water availability. So this paper was published in Cleaner Environmental System in 2021, and this is something where we have used the secondary information from different reports where they give some sort of data for service level benchmark of water supply utility. Now definitely this what is service level benchmark and all, you may have questions, so I'll try to clear it out to the best possible way in subsequent slides. So you get the full citation. This is also an open access journal, you can download it, you don't need any subscription. And as always, I have also given the QR code for easy access to this paper. So those who are interested to understand more the context specific things which are being presented in the paper, you can go through this paper. In this PPT, we'll just give some of the key findings, the procedure, the methodology, the way I have done for previous 3 lectures, that under different head, so that keeping the broad structure in mind about a research process, starting from identifying the gap, then objective, then formulation of the methodology, what method that you are going to use, and then finally how you report your information through images, through tables, through figures. So you can say that this lecture on all these case studies nothing but to just have a recap on all those kind of sequence says that we have discussed in our initial discussion of a research method. and process, but keeping the special emphasis on the quantitative research method in this particular case study. Moving ahead, so let us discuss the background why all of a sudden we thought of pursuing this kind of research. So developing countries like India face unique challenges in urban water management, and this is something always we debate that in our entire world we have so much of water, right? But then also why there is water crisis, especially in developing countries. And if you take example of Africa, South Africa, the situation is too serious. Many such kind of countries, they are under water stress. People, they don't have access to potable water or the safe drinkable water. So why it is happening? Because even if we have water everywhere, but only a very small fraction, 1 to 2%, are potable, like which we can consume, because rest of the things are like either in the glacier form or it is something like a saline water which we cannot consume. Definitely there are treatment nowadays, desalination and other processes are happening, but they are very costly affair. And whenever we talk about the developing country, they have certain kind of crisis with the economy, so situation is not really favorable. Now in this particular case, if you see that the issue is not only with the source of water or the treatment of water, many a times it is due to the management of the water. So the research said that around 40% of the water produced in Indian cities does not generate any revenue to its utilities. Now this is another concept which we also discuss in this particular PPT called NRW, non-revenue water. So what does it mean? So in a pipe or in a distribution system, there might be some of the water which may be discharged from the source, but it will not reach to the user because there are certain kind of physical damage in the pipe distribution or in the distribution system. So there is a loss. So even if you supply 100, probably you will get only 80. So 20% of water is actually not reaching to that end user. Or else somewhere when the water supply is metered and there is some sort of subsidy, there might be some sort of kind of unbilled consumption, so then also it is not accountable, right? So for this particular lecture, let us not go into much detail on NRW and this, because the main purpose of this case study to show you the approach, the methodology, the method that we have used, but this is something very important. So improper water management is crucial factor affecting the water crisis in urban areas more than the scarcity or stress. So it is something that even if you have the water, but we need proper management. Therefore, urban water management requires adequate attention from policymakers and researchers, because out of the research, when you develop certain strategy, come up with certain kind of decision or maybe some input which can finally evolve as policy. Coming to the research gap, literature across the world generally focus on the determinants of water consumption, that how we consume the water, not on that particular you can say the supply. The determinants of water supply have not widely been studied, so we thought of studying it based on secondary data. This study establishes the relationship between the water supply as one indicator and other influencing service level benchmark, which set by again Ministry of urban development that time in 2009. So in water supply we have total 9 such benchmark. I'll also talk about that. So we try to establish the relationship based on the data provided by different urban local bodies in different reports. So what are those serviceable benchmark? One is the coverage of water supply connection. This is the indicator, and the description of it, that it is the percentage of household with direct pipe connection where the benchmark is 100%. It is something that each and every household will have a connection. Many of the cities, they achieved it, but in some of the cases it is not, still it is in progress. Per capita water supply, that is something, from a long time it was assumed that okay, 135 liter per capita per day is the supplied quantity which can be averaged out. So definitely in a family, if I have say some elderly people, some young adults, some kids, their consumption will not be same, but on average it is 135, which actually is again something you can say that it is a supply level thought, because consumption may vary. Like somebody can use it like 150, somebody can use 120 and all. This is something the benchmark. Next one is the extent of NRW, that the extent of non-revenue water, where it is actually assumed that 20%, up to 20% is okay, but if it is 40% is a question, right? In some cities it is even higher. Extent of metering, that the meter water connection, which is also comparatively a new kind of approach for better utilization of the water. Like electricity, we all know that there is some meter based on unit, we have to pay some user charges, but for water in most of the cases it is not. So now it is in picture. Then continuity of water, where also it thought of that we should have 24 into 7, but in many cities it is the intermittent connection, that only a particular time in a day, or twice in a day, thrice in a day, even in some cases probably once in 2 days you will get that supply for certain duration, but the benchmark is 24 hours. Then efficiency of customer complaint readdressal, that there are certain sort of issues whenever there is a leakage, there are certain issues with the water. So how it is being addressed by the operators? So the benchmark that 80% of the complaints should be addressed. Next one is the quality of water supply at user end, so which is also like 100%, it is 100% quality assured, the safe. Cost recovery, percentage of operation and maintenance, this is also to be 100%. Efficiency in collection of water charges, again 90%. So now if you ask me that why it is 90%, why not, so probably at this moment I cannot give you any direct answer, but this is something based on what is desired to have. But obviously some of the cases, some of the cities, they are not meeting or they are not reaching to this particular value, but this is some sort of benchmark which are still existing. And then also there are certain sort of update that are going on in many academic research and all. We are focusing on how to make it much more comprehensive so that we can actually find out the issues and all. And across the globe they have such kind of performance measurement tool, indicators for all the utilities. Like this is, I just mentioned about water supply. Similarly we have for sanitation, sewage, and also for the urban transportation. So maybe if you are interested, you can search in Google that service level benchmark, you will get and you will find some interesting facts and figure. Coming to the objective of the study, the present study analyzes the relationship between per capita supply, what we thought of as a dependent variable, and other performance indicators discussed in the SLB, like other 8 indicators. Now for that particular case, initially we have gathered all the information available from different sources. Normally the urban local bodies, they upload, they publish these papers in the government their local website or their different dashboard. Now in this particular case we have concentrated on the cities that are projected to have a population over 1 million, means 10 lakh population by 2021, because this is the time where like 2019-20 when we initiated this research, and that particular time the latest data that we have with the population is 2011, and 2021, that time it is something like 2 years ahead of that research timeline. So we had to depend on the past data, and then we have to apply the projection. So for some cities, like where we have some kind of data for last 3 decades, in some cases we have some population where like data for only 2 decades, 2001 and 2011. So we have projected that data, and wherever we find the cities or the urban local bodies where the population is more than equal to 10 lakhs or 1 million, we have considered that in the present study. So this is the methodology of the study. So this is something in paper also. Sometimes you can give a flow chart which can attract the readers or the reviewers to just make a mind map that how this research has been done. So again, in this case, the review of unit water demand indicators across the globe, which is giving some sort of indicator idea, then review of service level benchmark for India. Then we try to understand the problem that water supply indicator is prevalent in India while consumption is studied across the world. So let us focus on the per capita supply or PCS. Selection of the cities is based on 1 million population and also the low surface water. So this is something where we have again referred to secondary information, where the entire India they have some sort of map on the low surface water availability, because there might be some sort of relationship that we assumed. Then we try to establish the relationship among the SLB indicators. We conducted the correlation analysis and then the multiple regression analysis, taking the PCS as dependent variable and other indicators which showcase some sort of strong correlation with PCS. We developed a linear regression. Then finally, what we have observed, the associated behavior of SLB indicators and indicators affecting the overall water supply. So from correlation matrix we can see that how they are influencing each other in terms of that information, and then also how they are impacting the per capita supply of water. Data collection, so secondary sources of data collection, and if you recall that this is early 2021, so it's the COVID time, so we thought of utilizing the secondary data to come up with certain kind of analysis. So we mostly relied on the secondary source of information. Then the surface water availability data has been collected from India Water Tool 2019. So they keep on updating. So the latest data that we have taken that. Census of India data 2001 and 2011 population we gathered, and then we projected it for 2021. Then government gadgets and other secondary sources have been referred to collect the service level benchmark performance data for all 9 indicators. Now if you go through this particular paper, as I mentioned that this is open access, you can easily download. So all the data for all these cities considered in the study, which is having projected population in by 2021 as 1 million, all such data are reported, right? All informations are not collected from the same source because it is different city, they might have different report and all. We have taken that information and then collate. So it is a nice compilation of the secondary data. If you think that it will be of some use, you can look at it. So this is what I was talking about, the low surface water availability map from Water Tool India, and you can see in this particular index that some of the parts, especially at the central India, that the low surface availability, because normally whenever we have some sort of river bank or maybe you have some sort of backwater, so you will get certain kind of higher surface water availability, but it is something at some places you really struggle. Then this map is the second map is for the surface water availability and SLB performance. In this case, it is just a category that all the cities which come up uh, as like 1 million population or even more than that, just 1 million with the smaller dot, and even some of them are having more than 10 million, they are coming at the bigger dot. And then if you just try to map this two, it is nothing but the extraction of the information. Say for example that this area Srinagar, they have some sort of high surface water availability and all, so you have these areas having some sort of color coding with that. Now coming to the rationale for the method, the correlation is a statistical technique adopted to explore the degree and direction of the association between two variables. So this is very important. If you recall the correlational analysis that I mentioned in early, I think in the first week or second week of this entire course, that this is something where you would like to know the relationship. Now one thing is that how strong the relationship is, and then the direction, that if increase in one will also increase the other, so it is a positive correlation. If increase in one will decrease the other, it is a negative correlation. So in reality, depending on the variables that you will pick up, you may end up with positive or negative, but along with the sign, the value also is very important. The correlation can vary from -1 to +1, and 0 indicates that there is no correlation. So whenever the value is close to -1 or close to, you can say, +1, we can say that is a strong correlation, strong positive correlation, strong negative correlation, etc. The SLB data was not normally distributed because this is just some data point that we have considered. So Pearson correlation was not appropriate. So we have used the Spearman correlation to see the association among the variables. After that, the multiple linear regression is another statistical technique which is used to establish the causal relationship between a dependent variable and other independent variables. That here we have taken PCS, the per capita supply of water is dependent on the metering or depending on the NRW, that okay, if metering is something like you impose metering, so whether there will be some check somewhere, like, so that we need to see. Multiple regression has numerous benefits such as ease of interpretation, robustness, and even in this case there are some sort of underlying assumptions. And then definitely whenever you go for this, there are certain sort of indicators, or you can say the measure of performance or maybe goodness of fit of the model, that in regression we always report along with the equation, we report the R square, which is again very important aspect of any linear relationship, that if the value is close to 1, so that means it is a better fit, or maybe the data that you want to make the regression, so they are meaningful and they are making sense. Now coming to the result straight away, there are other few results also, they are reported in the paper, but here I am just taking some of the important findings for just demonstration purpose. So this is something like a correlation matrix table look like, where you have row all the variables, and then you also have in column all the variables, and try to find out the correlationship. Now if you see diagonally, you will find it is always 1, because the correlation between PCS to PCS is 1. So this is some sort of you can say that the rule that is set. Next thing is that you try to establish the relationship based on the data. So the raw data for all the cities are there in the main paper, you can look into it. So based on that, this is the findings, where you can find that some of the relationship is having some negative signs and most of them are positive signs. So for negative we are denoting with the negative, but positive is just written as it is. But the values, if you see that 0.063 is a very weak, very weak correlation. It's almost close to 0. If you go with the rounding off, it is very close to 0. So normally for such kind of correlation, always we try to see the values which are like little above 0.4 or 0.5. If it is 0.7, 0.8, it is a very strong correlation, I would say. So in this particular case, you can see that the values which are having more than 0.35, because here the data was little heterogeneous, keeping in that perspective and looking at other few literature, we thought of highlighting the values which are having value more than 0.35 or 0.3 in this aspect, right? And you can see that how they are related. So now how to read this particular table, that is very important. Say in this particular case of PCS versus continuity. Now whenever like you say the continuity will be like higher, then PCS will be higher. So continuously you have to supply the water. So definitely in that case there will be more water that are putting into the distribution main. Similarly, if you just try to find out something, some relationship with the metering, so it is, even if it is low but it is minus, so if you impose the metering, so probably people will be alert and they will not use much. So the supply can be dropped in that aspect. Now coming to the linear regression in this particular case, so based on the correlation table and all, what finally we found that non-revenue water, continuity of water, then you have the coverage of water supply connection and the metering, these are making some sort of impact. So here also we have initially tried to develop with all the indicators, but then we found that they are not statistically significant. Then we also approach with the stepwise regression, and finally we come up with this sort of results, where each of them are giving you some sort of coefficient estimate and also the error. And now when you see this coefficient and standard error, then it will give you the value of the test statistics. So here in this case again we are using the T statistics that already we have discussed in the non-parametric parametric test PPT. So again in this particular case we thought of 5% significance level, so which is basically significance value should be less than equal to 0.05, or at the same time it is also can be referred as a 95% confidence level, which is the value should be greater than equal to 1.96, which is the case for all these three. Don't go with the sign now, I'll explain that. But for any such relationship, definitely whenever we take some independent variable and we estimate the model, assuming that these are the only factors which are affecting the dependent variable, so there are always some other factors which we fail to capture and which is also referred as a unobserved error, so which come up as a intercept of a regression equation. But in this particular case, if you see that even if in this equation we got certain coefficient, but the t value or this significance value, they are not really meeting the criteria. So that means this is particular value we cannot take. But again, the purpose of this particular model is not to go for a predictive model, that what would be the pieces, is just to establish the relationship. It's somewhat like a descriptive kind of model. So for that we keep this particular thing in this table, but definitely out of that we should not write a equation where you take this, because whenever a value or coefficient is not statistically significant, so it is as good as 0. So we can say that this coefficient is not statistically indifferent from 0. Now coming to the association, so here you can see with the continuity, it is having the maximum association followed by non-revenue water and coverage. And there is very, you can say that little impact, but then we cannot ignore, because it has coming up with a minus sign, that is your metering. So as I already mentioned, whenever something like, you must have seen that whenever things are available like public tap or something, that even if there are no takers, the water is just flowing through the drain and all. Or maybe in the household, that whenever there is no metering, even if we get our requirement, or we just uh, fill all the buckets or the tank that we have, after that we just waste the water in some cases. I am not saying each of us, but yes, it has been observed that there are wastage. Now instead of that, if we apply the metering, so there is some sort of metering how much water that you are using at your end, so always will be very much concerned about that, so as it will also impact the supply, right, definitely, and that is why something it is negative. Other than that, if you improve the NRW, that means you lower down that particular wastage, definitely you will get some sort of impact on that. So if you think that NRW value will increase further, that means much of the water is getting wasted, so you should plan for higher supply, so that at least the end user will get that. So that's why it is saying the positive thing. Continuity, if you want to maintain, you have to have higher supply, then coverage also will increase the supply, so that's why they are coming with a positive. But ideally NRW should be minimized to save the water, but here the relationship, if you find the NRW is more, so definitely the supply is more, but that will not guarantee that the same supplied amount will reach to the end user. So that is a serious issue. Coming to the discussion that water supply continuity, coverage, metering and NRW, they are having influence on per capita supply, that we have seen from this table, and that was also conveyed through the correlation matrix as well. The cities depicting high per capita water supply have high water losses as well. Therefore, the amount of water reaching to the resident is what actually it's less than what is reported. It is difficult to determine if the impact of NRW is either associated with the physical water losses or within financial losses, because it is a total loss. So NRW, non-revenue water, can be physical losses through the leakage, or sometimes maybe people are stealing water in between, or else it is unbilled supply, that there are some subsidies or free supply, so that this is something not making any revenue, there are no water charges, etc., etc. So altogether this is something like you can even read. That's why I suggest that those who are interested to know much more on this particular topic and all, you can go through the paper, and if you find any kind of problem, any doubt, you can always ask in the forum, so that I'll try to give the answer to best of my capacity. Coming to the conclusion of this study, the resident become more conscious of their water withdrawal when there is connection or meter. It's same like whenever you know that you have meter, the electricity and all, so when you leave the room, you always switch off the appliances. But for water, probably we don't, because we just assume that it is being supplied, right? So there is nothing like that. So that is something point by which we can control the water uses, and rather like the main intention is that if you save some amount of water somewhere, you can supply, because in many cases that some area they are supplied with more water and water are getting wasted, but some areas their lack of getting access to the water. So that's the concern. Urban local bodies can thus use metering of connection to encourage water conservation as a policy, which is also something like the global goal under SDG 6, right? So which will talk about the safe, accessible, drinkable water. And now you can see the other conclusion of the study is the continuity of supply influences the residents' behavior since they tend to store and use water accordingly. So whenever this is a concept you can just try to understand now, that if you have a continuity and you know that whenever you open the tap you will get the water, so you don't need to store the water, right? But in state of continuity of the water you have intermittent supply. That means you are not very sure that whether tomorrow you will get the water or not. You try to store more water, and next day if you get a fresh water, then it is a tendency that we have observed from the field, that then say that okay, why we stored that water, let it just throw it out, take the fresh water, even if without knowing that okay, within a day whether water qualities drops drastically or not. But that is a tendency. So maybe if we go for continuity, if people will have that confidence that okay, I'll be never short of water anytime, whenever I open the tap and I'll get the water, probably the storage and then wastage will be reduced. And still on that, as I mentioned, that the student is still working on some of the aspect, and then maybe in coming uh, days will come up with certain findings, and once it is published you can also get the more insight into it. Urban local bodies can focus on developing continuous water supply system rather than intermittent. That's the same reason that I have just explained. Now coming to the most important part of any of this case study, that is the takeaway from this case study. So the statistical method like correlation matrix or regression analysis can be employed in such kind of quantitative research where we try to establish the relationship between variables. It can be among all the independent variables like a correlation, partial correlation, or else it is something that you just try to see the influence of independent variables on dependent variables, which was the case here. The PCS was taken as dependent variable and other continuity metering in RW, those were taken as independent variables. Research identifies a significant relationship between per capita supply and other service level benchmark. So which is something from the secondary information, it's some useful information to see the relationship, because only reporting the values probably gives some sort of idea about okay, something is happening. But whenever we try to find out some sort of relationship among the data, that can eventually come up with certain sort of recommendation or strategy measurement which can help for the better management of water supply in urban local bodies or in urban area. Findings offer valuable guidance for urban local bodies and policymakers to enhance the urban water management, because if I just try to recall the initial slide, the background, that even if in some cases we have the water with us, but probably the management part somewhere we have to improve. So for that, this is something really giving some sort of direction. Hope you found it useful, some of the insights related to the method and also some of the context, the awareness about the water uses and different strategy by which we can actually improve the water supply or water infrastructure in a city for a better one can say performance. But still this is the area where even more research is required, and then if some of you are interested, definitely you can look into it and you can explore more such kind of research by which each infrastructure, I would say, that whether it is transportation, water, sanitation, power infrastructure, anywhere there are some research required to have a better performance, because things are there, things are moving, but we need it, whether it is from the management part, whether it is engineering part. Say for road infrastructure, definitely things are improved, new technologies, now different type of road materials are coming up, even overall the procedure, the machineries that are available now, we can construct kilometer after kilometer in a single day, which was not the case earlier. Similarly, even in the planning aspect, we are coming up with new things like e-vehicle, charging station, metro. We are now talking about the high-speed rail. So research in all these infrastructures are required, and to prove that there are certain sort of requirement, there are certain sort of relationship among those. If you increase this will impact like this. If you implement this, it will impact like this. So once you do all this analysis with certain kind of estimation, you can quantify those kind of impact. This will be eye opener, and definitely people will have more belief. Even if I just say that this has to be improved, but instead of that, if I say that if you improve, you will have this much of overall social benefit, or this will be the overall gain over this span of like years, then definitely that will be much more attractive to the investor or the policymaker to make it implement. So with all this, I would like to end here. To summarize, yes, definitely it is another uh, case study where we have seen the application of correlation and regression, how to establish the relationship and how it can help the policymaker for a better water management. With that, I end up this lecture here, and then we'll come up with the next case study, and that time, like, definitely, as because these all three are like little towards the planning, so I'll take up one example from architectural application as well in the next case study. So till then, thank you for joining the course, and then please do write to the forum so that I will understand the problems that you face. I have seen some of you have written some of the comments in earlier lectures and all, and I also try to give some better explanation, and will continue so that overall the purpose of this particular course will be fulfilled. Okay, so thank you very much for joining. We'll meet with our next lecture soon.